Lesson 6.5 is point, slope, form, and writing linear equations. So in the two previous lessons, we talked about the other two ways of writing a linear equation. You could write it as y equals mx plus b, or you could write it in standard form where ax plus by. So now this is point slope form. So if you look at this, it says, suppose you know that a line passes through the point 3, 4, and has a slope of 2. So they're giving you a point and they're giving you the slope. What you need to do is find the slope, which is right here, and you substitute 2 in for m. So then what happens is you have 3/4 in for xy, or x1 and y1. So you have y2 minus y1 over x2 minus x1. So that's what this is. These are really the little 2's. So y2 minus y1 is y2 minus 4, and x2 minus x1 is x2 minus 3. And that equals the slope of 2. So then what they're going to do is multiply both sides by this denominator because they want to clear the fraction. So if you see here, they multiply both sides by the denominator. So then you get y minus 4 equals 2 times the quantity of x minus 3. This is in slope point form, point slope form. So y minus 4 is the y coordinate, the slope is 2, and then the x coordinate goes at the end. So the point slope form is here. Y minus y1 equals m times the quantity of x minus x1. So that is your point and your slope. You only need one point, x comma y, and you need the slope of m to put them into those three places. So graph the equation y minus 5 equals 1/2 times x minus 2. So now it's pretty simple. It says the equation shows that the line passes through 2, 5. Now, notice that they got 2, 5 from here, the x coordinate and the y coordinate. Now, they're both positive because these are minus. It's y minus 5 and x minus 2. If you remember from this, the subtraction sign is there, and those are still positive numbers. So if it were to become a positive, it would be a negative. It would be the opposite. So it goes through 2, 5 and has a slope of 1/2. So you have 2, 5, and then you have rise over run. And then you have your graph. So try this one. Graph the equation y minus 5 equals negative 2/3 times x plus 2. So you're going to draw your graph. Just like up above, you have your two numbers. Now this one's still at 5. Now this one is x plus 2. So that means my x coordinate is going to be negative 2 because it's the opposite. Two negatives make a positive, and this is a positive 2. So two negatives make it positive, and then that's 5. So my x coordinate is negative 2 and then up 5. I make a dot. And then I do my slope. Now this time my slope is negative 2/3. So I'm going to go down 2 and over 3. And then I'm going to draw my line. All right, writing an equation in point slope form. So it says write the equation of the line that has the slope negative 3 that passes through the point negative 1 comma 7. So you have your equation right here, and then you're going to plug in 7 for y1, negative 3 for m, and negative 1 for x. And then if you notice right here, these two negatives make it a positive, so it's y minus 7 equals negative 3 times the quantity of x plus 1. So try this on your own. Write the equation of the line that has the slope 2/5 that passes through the point 10, negative 8. So you have your equation y minus y1 equals m times x minus x1. So then I get y minus negative 8 equals 2/5 times x minus 10. So y minus negative 8 is y plus 8, equals 2/5 times x minus 10. All right, example 3 says using 2 points to write an equation. So write equations for the line in point-slope form and in slope-intercept form. So they're just going to give you a graph. Okay, so here's my graph. Now they want it written in 2 different ways. So this is going to take 3 steps. Step 1, you need to find the slope because you're going to use it in both equations. So you find the slope, which is 8/3. So 1, 2, 3, 4, 5, 6, 7, 8. Rise over run. So that's 8/3. Now use either point to write the equation in point-slope form. So it doesn't matter which point you use. So they picked 2, 3. So then they did y minus 3 equals 8/3 times the quantity of x minus 2. It wouldn't matter. You could use either point. And then when you write it in slope-intercept form, you have the slope and then you have the y-intercept, which is 2 1/3. Now, you really can't tell what the y-intercept is based on the graph because you'd just be guessing, and you don't want to ever just guess because it's not at an exact point. So what they did is they took the point slope form from here and then they solved it. So they distributed 8/3 to x minus 5 1/3, and then they added 3 to both sides. And then you get your slope-intercept form. So try this. Write an equation for the line in example 3 in point-slope form using the point -1, -5. So you're going to use the other point. So on here, write the equation using this other point right here. Okay, so -1, -5. So you would have y minus y1 equals m times x minus x1. So I'm going to have y minus -5 equals, what was the slope? 8/3 times x minus -1. So that's y plus 5 equals 8/3 times x plus 1. And it says write the equation you found in part A in slope-intercept form. So now it wants us to change it. So then I would have y plus 5 equals 8/3x plus 8/3, which if I rewrote that, it would be 2 2/3. And then I'm going to minus 5 from both sides. So then you get y equals 8/3 x minus 2 1/3. So look, what do you notice? It's the exact same equation. 8/3 x minus 2 1/3. Exact same equation, but I used the different point. It doesn't matter what point you use, you'll still get this same equation if you write it in slope-intercept form. All right, writing an equation using a table. Is the relationship shown by the data linear? If so, model the data with an equation. So I'm going to look at this and I'm going to say, okay, it goes up by 4, then 2, then 6. So it's not going up steadily on x. On y, it goes up by 2, and then 1, and then 3. So I'm going to divide it. So I'm going to put 2/4 right here. And then I'm going to put 1/2, rise over run, and then I'm going to put 3/6. Oh, well, then I can see that my slope is 1/2. It just isn't a nice, perfectly set up table. There's just kind of random. So then you pick a point and you substitute. They picked 5, 7, and they put it into point slope form. So they did -7 equal, y minus 7 equals 1/2 times the quantity of x minus 5. So then that was the equation. So try this. Is the relationship shown by the data at the right linear? If so, model the data with an equation. So first I'm going to find the slope. So this is going up by 10. This goes up by 5. This goes up by 15. And then this is going up by 4. This is going up by 2. And this is going up 6. So then you'd have, excuse me, 4/10, which is 2/5. And then you'd have 2/5 and 6/15, which if you divide by 3 is 2/5. So 2/5 is my slope. So I'm going to pick a point, 19.5. So I'm going to do y minus 5 equals 2/5 times x minus 19. And that's your equation. So you have 3 different types. You have slope-intercept form, y equals mx plus b. You have standard form, ax plus by equals c. And you have point slope form, y minus y1 equals m times the quantity of x minus x1. So you have 3 different ways you can write the same type of an equation. They're all linear. All right, that is it.